Welcome to Pratham Science Academy classes, and we are about to start set 4 of year 2024, and this is the subset 1 of set 4. So for section A, question number 1, it says that this is a scalar matrix, and then we have to find the value of A plus 2B plus 3C plus 4D. Now, we know that scalar matrix is a matrix in which So this is a diagonal matrix in which all the diagonal elements are equal and rest of all elements are zero. So the scalar matrix is so this is scalar matrix is first of all it is a square matrix in which all diagonal elements are equal and the rest of all elements are zero. So that means if it's square matrix of order 3, then its principal diagonal elements will be all equal, let's say k, 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 and all these elements will be 0. So that means these are the diagonal elements. So A is equal to D is equal to 5. Now this C is 0. If we compare this with the scalar matrix, so C is equal to 0. And okay, so we have got and we have B is also equal to 0. So let's put these values in this, which gives us A is 5, 2 into B is 0, 3 into C is 0, plus 4 into D is 5. So this is now 5 plus 20, which is equal to 25. So 25 is the correct answer for the question number 1. Okay, for question number 2, it's given that A inverse is equal to 1 by 7, and this is the matrix. So we have to find out what is matrix A. Now it's given that A inverse is equal to 1 by 7 into 2, 1 minus 3 and 2. Now we know that the A inverse is given by adjoint of A divided by determinant of A. Now if we compare these two sides, this is adjoint of A and this is the value of determinant. So this is determinant of A, which is 7. Now, if we look at all these matrices that are given to us, this is the one that has the determinant A. So if we find the determinant, if we take determinant of this, this is 2 into 2 is 4 minus 3 into negative 1 is negative 3. So 4 plus 3 is equal to 7. That means the determinant of this matrix is 7. So that means this is the A matrix. So B is the correct answer for this one. Okay, for question number 3, A is a square matrix of order 2, and we have to find the value of I, where I is identity matrix of order 2, A plus A squared minus A cubed, and so on. So let's find out the value of A squared and A cubed first. So I is an identity matrix of order 2. So that means the diagonal elements are 1 and all other elements are 0. So this is I. And A is given to us, which is 2, 1, negative 4, and negative 2. Okay, now let's find out A squares. So A square is the product of A into A, and A is 2, 1 minus 4 minus 2 into 2, 1 minus 4 and minus 2. Okay, so this is equal to, so 2, this row and this column. 2 into 2 is 4, 1 into negative 4 is negative 4, then 2 into 1 plus 1 into negative 2. So negative 8 and plus 8, negative 4, and plus 4. So this 4 minus 4 is 0, 2, negative 2 is 0, 0, 0. So a square is 0. So that means all other element of this, where a has power 4 or has power 6 or has power a, that is a with even power is 0. Now let's find out a cube. So a cube is a square into a. Now a square is a null matrix with all elements 0. And if you multiply this a, which is a non-zero matrix, so this is going to be 0 as well. So that means if we write this equation, that is I minus a plus a square minus a cube and so on, all these matrices are 0. So we are left with only I minus identity matrix minus a. So identity matrix minus a. So this equation is reduced to I minus a, and I is 1 0 0 1. We have to subtract the matrix A, which is 2 1 uh, minus 4 and minus 2. Okay, so 1 minus 2 is negative 1, 0 minus 1 is negative 1, 0 minus of minus 4 is 4, 1 minus of minus 2 is 3. So this is negative 1, negative 1, 4, 3, and negative 1, negative 1, 4, 3. A is the correct option for this, for question number 3. For question number 4, A is a square matrix of order 3, and we have to find the determinant of A into adjoint A. So first of all, let's find the adjoint of A, and for that, we have to find the cofactors A11, A12, A13, and I'm going to assign them signs. 1 plus 1 is 2, which is even, so positive sign. For odd, if the sum of I and j is odd, it's negative, so plus. And removing the row and the column for the respective elements. So this gives me 2, 3, 1, negative 1, which is equal to negative 2, negative 3, which is equal to negative 5. And this is A12. So A12 is removing the row and the column for that. It's negative 2 into 0 and 5 into negative 1. So negative of 2, which is negative 2. Okay, this is negative. Remove the row and the column for that. This one, it gives 1 3, 1 3 5, and negative 1. So this is equal to negative, negative 1, negative 15, which is equal to 16. For the third one, 1 3, remove the row and the column for that, and it's 1 2 5 and negative 1. So this is now negative 1 and negative 10, which is equal to remove the row, so 1 2 5 and 1. This is 5 1. So this is now 1 minus 10 is equal to minus 9. And to get the joint of A, we will write these cofactors in the column. So negative 5, 16, and 9. Similarly, we can find the cofactors A to 1. So find out A to 1, A to 2, and A to 3. So these cofactors will be A to 1. So A to 1 will be 0. So this is 0, this is 2, and this is 2. So we have got the second column 0 to 2, and similarly find out A31, A32, and A33. So A31, A32, and A33 will be 0, 6, and negative 4. So this is 0, 6, and negative 4. So this is 0, 6, and negative 4. This is a joint of A. Now we have to find Let's find out the product of A into adjoint A. A matrix is negative 2, 0, 0, and 1, 2, 3, 5, 1, negative 1. This is A, and we have to find its product with adjoint of A. So adjoint of A is it's negative 5, 0, 0, and 16 to 6, 16 to 6, and then negative 9, 2, and negative 4, negative 9, 2, and negative 4. Okay, if we multiply them, I'm going to get this is 10, 0, 0, and once again it's 0, 10, 0, and 0, 0, 10. So this is A into adjoint A. Okay, now A into adjoint A, if we take 10 common in all the three rows, so this is 10 into 10 into 10, and this is an identity matrix left 1, 0, 0, 0, 0, 1, and sorry, 0, 1, 0, and 0, 0. This is 0, 0, 1, 0, 0, 1. Okay, so finally we have A into adjoint A is equal to 1000 into identity matrix, but we have to find the determinant. So determinant of identity matrix is 1, so this is 1000 into 1 is equal to 1000. So D should be the correct option for this one. So this is the correct option, that is D, which is 1000. Okay, for question number 5, value of x for the given product of these matrices, which is equal to 0. So this is 1 into x, and the other matrix is 4 into 0, negative 2, 0, which is equal to null matrix. So first row with first column 1 into 4 is 4x into negative 2 is negative 2x, and with the second column it's 1 into 0 is 0, and x into 0 is 0. So this is negative 4, 4 minus 2x is equal to null matrix. So that should have two elements 0 as 0. So 4 minus 2x is equal to 0. So negative 2x is equal to negative 4, which gives me x is equal to 2. So C is the correct answer for this one. Actually, this should be 1 into 4 is 4, and okay. Okay, for question number 6, we have to find the derivative of e raised power 2x with respect to e raised power x. And for this, let's say our function e raised power 2x is y, and e raised power x is z. And to find the derivative of this with respect to z, we have to find dy by dz. To find dy by dz, let's first differentiate this with respect to x, which gives me dy by dx, and differentiation of e raised power 2x is e raised power 2x multiplied by the differentiation of 2x, which is 2. Now differentiating this function with respect to x gives me e raised power x, because the differentiation of e raised power x is e raised power x. Now we have to find dy by dz. For that, we divide dy by dz with dz by dx, which gives me e raised power 2x into 2 upon e raised power x. So for this, it's e raised power x into 2. So our answer is 2 into e raised power x, which is option B. Okay, for question number 7, we have to find the value of k for which the function given below is continuous at x is equal to 0. And our function is this. So we know that for the continuous function, left hand limit is equal to right hand limit is equal to value of the function at x, and x is 0. So let's take the condition that the function is continuous. So function is a continuous function. That means the limit of the function at that is x tends to 0 for the function should be equal to value of the function at x is equal to 0. Now, the limit of the function when x is not equal to 0 is a given. So let's put down the value of the function for this, which is the root of 4 plus x minus 2 upon x is equal to f of 0. Now the value of the function at x is equal to 0 is k. So this is k. Let's try to simplify this to get the limit. And to do this, we are going to rationalize 4 plus x minus 2 upon x into, let's rationalize this. This is 4 plus x plus 2. Use the conjugate, and this is equal to 2. Now this is of the form a minus b into a plus b, which leaves us with limit x tends to 0. So this is a square, that is under root 4 plus x the whole square minus 2 square upon x into under root of 4 plus x plus 2, which is equal to k. So this gets cancelled. And now we have limit x tends to 0. This is 4 plus x minus 4 upon x under root 4 plus x plus 2 is equal to k. And limit x tends to 0. This is x upon x. 4 plus x plus 2 is equal to k. X and x gets cancelled. Now we can take the limit here. That is, put the value of x is equal to 0. So if we taking limit here gives us 1 upon under root 4 plus 0 plus 2 is equal to k, which gives us 1 upon root 4 is 2, 2 plus 2 is 4, which gives us k is equal to 1 by 4. So k is equal to 1 by 4 means B is the correct option for this. So for question number 8, we have to find the value of the given definite integral. Let's say our integral is I is equal to integration limits are 0 to 3, and this is dx. Now this can be written as 9 is 3 square minus x square. Now this is of the form integration of under root a square minus x square, which is equal to sine inverse x by a plus c. So this is now equal to sine inverse x by a is 3, and the limits are 0 to 3. So this is equal to sine inverse 3 by 3 minus sine inverse 0 by 3, which is 0. So this is sine inverse 1, and sine inverse 1 minus sine inverse 0. Now the angle for which the value of sine is 1 is 90, so this is pi by 2. Angle for which the value of sine is 0 is 0, so this is equal to pi by 2. C is the option for this. Okay, for question number 9, we have to find the general solution of the differential equation given as. So our differential equation is x into dy plus y into dx is equal to 0. We can easily separate the variables in this case. So y into dx is equal to x into dy, which gives us this can be written as let me write it as this is x into dy is equal to negative of y into dx. And if we separate the variables, this is dy by dx, or this is dy upon y is equal to dx upon x. Let this be negative. And to solve this, we are going to integrate this on both the sides. So taking the integral on both sides, we get this is the integral of 1 by y is log y. This is negative log x plus c. Now, or c is a constant, so that could be a log. So log of c. Now this can be rearranged as log y plus log x is equal to log c. This is log a plus b, which is equal to log a into b log. This is log c, which gives us c is equal to xy. So this is the general solution, and our option is a, c is equal to xy. A is the correct option for this one. On question number 10, we have to find the integrating factor of the differential equation. And the differential equation is x plus 2y the whole square into dy by dx is equal to y, where y is greater than 0. So let's try to get this in the linear differential equation form. And these are either of the form dy by dx plus px is equal to q, sorry, dy is equal to q, or dx by dy plus dy is equal to q. Let's try to get into one of these forms. And I can write it as dy by dx is equal to y upon x plus 2y the whole square. Now this can be written as dx by dy is equal to x plus 2y the whole square by y is equal to x by y plus 2y square by y. And finally, this becomes dx by dy is equal to x by y plus 2y. And dx by dy is equal to negative x upon y is equal to 2y. And if we compare this with the standard form of linear equation, which is dx by dy plus this should be equal to px plus q. And if we compare these two, here p is equal to negative 1 by 5, which gives us the integrating factor. So integrating factor is given by, in this case, integrating factor is integration of p into dy. So this is integration of p is negative 1 by y into dy. So this is integration of negative is out. Integration of 1 by y is, this is negative log y, which can be written as e log of y inverse, which becomes e log of 1 by, which is equal to 1 by y. So 1 by y is the correct option, which is option D. So D is the correct answer for this one. For question number 11, it's given that A and B are two vectors and the magnitude of A is 1, magnitude of B is 2, and the dot product of A and B is √3. We have to find the angle between 2A vector and negative of B vector. So this 2A, and let's find out the dot product of this. This can be written as negative 2A dot B. Now A dot B is √3, so this becomes negative √3. We can use the alternate method, that is the dot product to, that is A dot B is equal to magnitude of A into magnitude of B into cos theta. So I can write this as magnitude of 2A into magnitude of B vector into cos theta. Now this I have calculated here, evaluated here. This is negative 2 root 3. Now 2, this can be written as 2 into magnitude of A, magnitude of negative magnitude of B is equal to magnitude of B, because we have to square the scalar components to get the magnitude. So this can be written as the positive magnitude of B. Now, let's substitute these values. A vector, magnitude of A vector is 1, magnitude of B vector is 2. So this is cos theta, 2 and 2 gets cancelled. And finally, we have cos theta is root 3 by 2. So we know that cos is negative in the second quadrant and root 3. Uh, for cos 30, it's root 3, and cos 30 means it's for 5 by 6. Okay, to get in the second quadrant, it has to be pi minus pi by 6. I can write this as cos of pi minus pi by 6, which is equal to root 3. So that becomes cos 5 pi by 6. This becomes negative. So this is cos, I can write this as cos of 5 pi by 6. Sorry, cos 5, cos of 5 pi by 6 is negative root 3 by 2. So this is equal to negative root 3 by 2. So that means theta is equal to cos of 5 pi by 6. I have written this by taking the base angle for the value root 3 by 2, which is pi by 6. So cos pi by 6 is root 3 by 2, and cos is negative in the second quadrant. To remain in the second quadrant, it has to be pi minus pi by 6, which gives us the negative cos root 3 by 2. So it's cos pi pi by 6. So theta is equal to 5 pi by 6, which means C is the correct option for this one. So the for question number 12, the vectors A, B, and C are given, and we have to show that if these are the sides of an equilateral, obtuse angle triangle, isosceles, or right angle triangle. So let's try to find out the magnitude of these. So magnitude of A is the sum of the square of the scalar components and their root, negative 1 square plus 1 square under root, which gives us 4 plus 1, which is equal to under root 6. Now, finding the magnitude of B, which represents one of the sides of these, the triangle, given triangle. So this is 1 square plus negative 3 square plus negative 5 square, which is equal to 1 plus 9 plus 25, which is equal to under root 35. Okay, now magnitude of C vector is equal to negative 3 square plus 4 square plus 4 square under root, and that is equal to 9 plus 16 plus 16, which is equal to under root 41. Now, here the greater side is this. So if we make the square of the smaller sides, that is square of under root 6 plus square of under root 35, which gives me 6 plus 35 is equal to 41, which is equal to the square of magnitude of C. So A square plus B square is equal to C square. So that means these are the sides of a right angle triangle, because the magnitude of the square of sum of the square of the two sides is equal to the square of the largest side, which is a Pythagoras theorem, and this happens only in a right angle triangle. So D is the correct option for this one. Okay, for question number 13, it's given that A be any vector such that magnitude of A is equal to A, and we have to find the value of the magnitude of A cross I cap square plus magnitude of A cross J cap square. So let's say our A vector is given by X I cap plus Y J cap plus Z K cap. Now let's try to find out all these cross products first, and then their magnitude and then their square. So cross product of A with I cap. Now our A vector is x I cap plus y j cap plus z k cap. It's cross with I cap. So I can write this as x into I caps cross with I plus y into j cap cross I cap plus z into k cap cross I cap. Now I cap into I cap is cross. So I cap cross I cap is 0 because we know that the cross product is given by A cross B is AB sine theta. Now angle between this is these two is 0. So this is magnitude of I cap into sine 0. So is a unit vector. So this is 1 into 0, which is equal to 0. So this is 0. Now what is J cross I cap? And we know that I cap, this is x-axis, y-axis, and z-axis. Direction along x-axis is given by I cap, along y is given by j cap, and along z it's given by k cap. And if we move this anti-clockwise, so I cap cross j cap is equal to k cap, but it's j cap cross I cap, which is equal to negative k cap. This is y into negative k cap plus z into similarly k into I cap. So k into I cap is j cap. So this is our cross product of A with I cap. Now let's find its magnitude. So magnitude of A vectors cross with I cap is equal to, this is 0. So this finally becomes negative y k cap plus z j cap. Its magnitude is negative y square plus z squares under root, which is equal to y square plus z square. And if we have to find the square of this, so this is under root, and this is now y square plus z squares square. So this gets cancelled, which is equal to y square plus z square. Similarly, we can find out the square of the magnitude of A vector with j caps, the square of the magnitude of cross of A with j cap and A with k cap. So A with k cap cross products square of the magnitude of the cross product. So this was equal to y square plus z square, and this is second one. This is equal to x square plus z square. So this is equal to x square plus z square, and the third one should be equal to x square plus y square. Now let's add all of these. So this is a cap, a vector cross I caps magnitude square. So a vector cross j caps magnitude square. So a vector cross k cap magnitude square. We have to add them. So plus. So we have to add these, which is 2 times x square plus 2 times x square plus y square plus z square. Now our A vector was this, and if we find out its magnitude, so this is x square plus y square plus z square under root, and if you have to find out its square, so this is now equal to A square. So A square is equal to x square plus y square plus z squares under root square. So that means x square plus y square plus z square is A square. So I can, instead of this, I can write 2A square, which is the magnitude of the square of A, and which matches with the option B. So B is the answer for this one. For question number 14, we have to find the vector equation of a line passing through the point and parallel to y-axis. Now, vector equation of a line passing through a given point is given by its r vector is equal to a. This is r vector is equal to a vector plus lambda into b vector, where a is the position vector of the point through which it passes, and the position vector is equal to the position vector of this point is a vector, which becomes I cap minus j cap plus 0 into k cap. So this is I cap minus j cap. So r vector is equal to I cap minus j cap plus lambda into b vector. Now this b vector is the vector which is parallel to the y-axis, parallel to the line. So if it's parallel to the line, line is parallel to the y-axis. So if this line is parallel to the y-axis, then it makes angles. This is perpendicular to x and z axis. Now the angle with the x axis is alpha, which is 90-degree. Angle with the z axis is gamma, which is 90 degrees. So this is parallel to y axis. So angle with y axis is 0. So now this b vector can be written as cos alpha into I cap plus cos beta into j cap plus cos alpha into k cap, where cos alpha, cos beta, and cos gamma are the direction cosines. So cos alpha is 90, which is 0. So this is 0 into I cap. Cos beta is 0. So this is cos beta, which is 0. So this becomes cos beta. Beta is 0. So this becomes 0. Cos 0 is 1. So this is 1. So beta is 0, so cos 0 is 1. So this is 1 into j cap. Now cos gamma. Gamma is 90, which becomes 0. So this is 0 into k cap. So b vector is equal to j cap. So this can be written as our required equation of the line is I cap minus j cap plus lambda into j cap. And this is the option B. So B is the correct one for this question number 40. For question number 15, we are given with the Cartesian equation of two lines and they are perpendicular to each other. So we have to find the value of p. And we know that the standard equation of the Cartesian equation of line is given by x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where x1, y1, z1 are the coordinates of the point through which it passes, and a, b, c are the direction ratios. So let's try to get these equations in the standard form. So let the first one be the line L1, and I have to get this in the standard form. So this, let me take negative out. So this x minus 1 by 2 is equal to y minus 1 by 3 is equal to z minus 0 by 1. And so now this is the standard form. And its direction ratios are A, B, and C, which are negative 2, 3, and 1. So let this be, so these are the direction ratios. So let this be A1, B1, and C1. Similarly, let the second be the line L2, and this is 2x minus 3 by 2p is equal to y by negative 1 is equal to z minus 4 by 7. Let's write this down in the standard form. Take 2 common. So 2 into x minus 3 by 2 by 2p is equal to y by negative 1 is equal to z minus 4 by 7. Now this can be written as, this gets cancelled. So this is x minus 3 by 2p is equal to y upon negative 1 is equal to z minus 4 by 7. So this is now in the standard form, and its direction ratios are A2, B2, and C2, which are P negative 1 and 7. And since this lines L1 is perpendicular to L2, so the sum of the product of the direction ratios, these are the direction ratios. So sum of the product of the direction ratio should be equal to 0. And so this becomes -2 into P plus 3 into -1 plus 1 into 7 is equal to 0. So -2 minus 3 plus 7 is equal to 0. This is -2 is equal to -4, which gives us P is equal to 2. So P is equal to 2. C is the correct option for this one. So for question number 16, we have to find the maximum value of Z whose feasible region is given below. And for this, we are going to write down the corner points and we will evaluate the linear equation Z for those corner points. And the first corner point is A, which is 0, comma 50. And it's A, and the second corner point is B, which is 20, comma 30. This is 50. And then C, it's 30, comma 0, and then D, which is the origin. So for A, this is X, this is Y. The value of Z is 50. For B, 20, comma 30. So 4 into 20 is 80 plus 30 is equal to 110. This is 30 into 4 is 120. This is 0. And we have to find the maximum value of Z. So maximum value of Z is 120, which is option C. So for question number 17, we have to the probability distribution table of a random variable x is given where x is some unknown constant and the probability that the random variable x takes the value 2 is. So for this, we have to find the value of k, and we know that the sum of the probabilities of all the events, that is the sum of the probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. These are all the events and they should be equal to 1. So probability of x is equal to 0 is zero point 0.1. This is k plus 2k plus k plus zero point 0.1 is equal to 1. So zero point 0.1 and zero point 0.2. So this is 1 minus zero point 0.2. This is k plus 2k plus k. This is 4k. So 4k is equal to zero point 0.8 and k is equal to zero point 0.2. So the k is equal to zero point 0.2 and we have to find the probability when the random variable takes the value 2. So that is we have to find the probability of when the random variable takes the value 2 and it's 2k. So this is 2 into value of k is zero point 0.2. So this is equal to zero point 0.4. Now zero point 0.4 can be written as 4 by 10, which is equal to 2 by 5. So B is the correct option for this one, question number 17. Okay, for question number 18, we have to find the value of k or choose one of those options for which the given function is strictly increasing and our function is f of x is equal to kx minus sine of x. Now, we know that for strictly increasing function, f dash x should be greater than 0. Now, f dash x differentiation of this is k minus cos x is greater than 0. So now this k minus cos x is greater than 0 when k is greater than cos x. Now we know that the range for cos x is greater than equal to -1 but less than 1. That is the maximum value of cos is 1. So for this to be positive, k should be greater than 1. So that means for this to be positive, k should be greater than 1. and which is the option A. So A is the correct option for question number 18. Okay, for question number 19, which is assertion and the reason-based questions carrying 1 marks each. For question number 19, the assertion says that relation R, where xy is an ordered pair, is such that x plus y is a prime number. So if x plus y is a prime number, we say that x, y are in relation and x, y belongs to natural numbers. So our domain is natural number and codomain is also a natural number. And say that it's not a reflexive relation. And our relation is xy ordered pair such that x plus y is a prime number. And we have to show that it's not a reflexive. So relation is reflexive when we are able to show that x is in relation with x. So let's consider an element natural number here, let's say 3 and 3. Now 3 comma 3 is not in relation because 3 plus 3 according to relation the sum should be a prime number, but 3 plus 3 is equal to 6, which is not a prime number. So that means 3 is not in relation with 3 is not in relation with 3. So it's not in relation with 3, so that means that relation is not reflexive, so that means this statement is true. And now the next reason is not the for assertion, this is not the correct reason. So these are two different statements. The number 2 one is composite for all natural numbers n, which is not true, because if we consider n is equal to 1, so which gives us 2 into 1 is equal to 2, which is a prime number. So it's not always a composite number. So that means that this reason that's given as a statement is false, and this is not the correct explanation of A as well. So we can say that assertion A is true, but reason R is false. So C is the correct answer for this one. Okay, for question number 20, the assertion says that the corner points of the bounded feasible region of the LPP are shown below, and the maximum value of Z is equal to x plus 2y occurs at infinite points. Now, this could be true when we have uh, the maximum value at 2 points, and the line joining those 2 points will have infinite number of points where we will get the maximum value of Z. I will show you how. So let me write down the corner points. Our corner points are, first corner point is R, which is 60 comma 30. The other corner point, this is R, and then S we have 40 20, then P, which is 60 0, and then Q, which is 120 0. And let's find the maximum value of Z at all these corner points. So if we put this the values of x and y in this, it gives me, this is 60 plus 60 is equal to 120. Now this is 40 plus 40, which is equal to 80, and this is 60, this is 120. Now we have the maximum value at these 2 points, which are R and Q. So we have the maximum value at R and Q, that means that the line joining these 2 points will have infinite number of points, and at each of these points joining the line R and Q, we will have the maximum value of Z. So the first statement is assertion is true because the corner points of the bounded feasible region of the LPP, which are given below the maximum value of Z, occurs at 2 points, and we will get infinite number of points if we join these R and Q. So for every point on R and Q which are infinite, we will get the maximum value of Z. So this is true. Now the optimal solution of a LPP having bounded feasible region must occur at corner point. This is also true, but this is not the correct explanation of assertion. So in this case, our option, if we choose the option from given options. So R correct, in this case, the correct option is both A and R are true, but R is not the correct explanation of A. So B is the correct option for this one. So this is option B. Both assertion A and R are true, but R is not the correct explanation of A. So B is the correct answer for question number 20. For question number 21, part A, we have to express tan inverse of cos x1 minus sin x in the simplest form. And these are very short answer type questions of 2 marks each. So our expression is tan inverse. This is cos x upon 1 minus sin x. Now, our objective will be to get all this term in terms of tan. So for this, we are going to use this golden formula, that is cos 2x. We know that cos 2x is cos square x minus sine square x. So if we take half of this angle, so if we take x, this becomes x by 2. So that means I can write tan inverse, instead of cos x, I can write it's cos square x by 2 minus this is sine square x by 2. Okay. And for sine x, we know that sine 2x is 2 sine x into cos x, and half of this angle, that means sine x will give me 2 sine x by 2 into cos x by 2. So I can write this as, instead of this, and for 1 I can write it as cos square x by 2 plus sine square x by 2. So I have replaced 1 with cos square x by 2 plus sine square x by 2, because this is 1 negative. Now sine x is 2 sine x by 2 into cos x by 2. Okay, now this is tan inverse. So this is a square minus b square. I can write it as a minus b into a plus b, and this becomes a square plus b square minus 2ab, which is a minus b the whole square. Okay, so finally we are left with tan inverse. This is cos x by 2 plus sine x by 2 upon cos x by 2 minus sine x by 2. Now let's divide each and every term by cos. So if we divide this with cos, this is 1. If I divide this with cos, this is tan x by 2. So I am dividing numerator and denominator by cos x by 2. That is, divide each term with cos x by 2, which gives me tan inverse of 1 plus tan x by 2 upon 1 minus tan x by 2. Now 1. I can write 1 as tan of pi by 4, because tan of pi by 4 is 1, and this is tan of, instead of 1, let me keep this as 1, and I can write this as 1 into tan x by 2. So this is, for 1 I can write 1 minus tan pi by 4 into tan x by 2. Now this is of the form tan a plus b, because we know that tan a plus b is tan a plus tan b upon 1 minus tan a into tan b, where a is pi by 4 and b is uh, x by 2. So for this, I can now write this is tan inverse tan of a plus b. And now the simplified form is pi by 4 plus x by 2. So that means the tan inverse cos x upon 1 minus sin x is equal to pi by 4 plus x by 2. Okay, for question number 21, part B, we have to find the principal value of tan inverse 1 plus cos inverse negative half plus sin inverse negative 1 by 2. So let's find out the value of tan inverse 1. So let's say y is equal to tan inverse 1. So this is tan y is equal to 1. And we know that 1 is tan pi by 4, which gives me y is equal to pi by 4. So this is equal to pi by 4. So tan inverse 1 is pi by 4. And now let's find out the value of cos inverse negative half. So let's say y is equal to cos inverse negative half. So this is cos y is equal to negative half. And half, we know that cos pi by 3 is half. And cos is negative in the second quadrant. So I will keep this in the second quadrant by pi minus pi by 3, which gives me y is equal to pi minus pi by 3. So this value is pi minus pi by 3. So pi minus pi by 3 is the value of cos inverse. Next is sine inverse minus 1 by root 2. So let's say y is equal to sine inverse minus 1 by root 2, which gives me sine y is equal to negative 1 by root 2. And I can write this as negative of sine of pi by 4. And now sine y, we know that negative sine x is equal to sine of negative x. So this can be written as sine of negative pi by 4. So y is equal to negative pi by 4. So this is negative pi by 4. And if I put the value here, this is negative pi by 4. So let's simplify this now. So this gets cancelled, and pi minus pi by 3 is 3 pi minus pi by 3, which is 2 pi by 3. So 2 pi by 3 is the principal value of this, 2 pi by 3. Okay, for question number 22, part A, we have to find the differentiation of y with respect to t. So let's start differentiating this with respect to t. So differentiation of y with respect to t is dy by dt. Now for this is the differentiation of the form x raised power n, where x is cos of secant square 2t and n is 3. So this is n into x raised power n minus 1. So this is n is 3, 3 into x cos square raised power secant square 2t. Now the differentiation of cos is negative, so this is negative sine into of secant square 2t, and now we have to differentiate secant square 2t with respect to t. Okay, so we can write this as dy by dt, and negative, let's take it in the front. So this is 3 cos square secant square 2t into sine of secant square 2t. Now we have to differentiate secant square 2t with respect to t. So differentiation of secant square. Here once again we are going to use the formula x raised power n. Differentiation of the same formula for this. So this is 2 into x raised power n minus 1 is 1, so 2t. And now the differentiation of secant 2t. Okay, so differentiation of secant. So what is the differentiation of secant? So differentiation of secant is secant into, okay, so finally we have, let me just write it down. So this is dy by dt is equal to negative 3 cos square secant square t 2t into sine of secant square 2t into 2 secant 2t. Now differentiation of secant x is secant x into tan x. So this is secant x into tan x and differentiation of 2t which is 2. So finally our differentiation is so negative 3 into 2 is this is negative 6. Uh, okay, 2 this is negative 6 into 2 is negative 12. So this is negative 12. And we have cos square. So let's write this as cos square secant square 2t. And then we have sine of secant square 2t. And this is secant 2t into secant 2t is secant square 2t into we are left with tan 2t. So this is the value of dy by dt. Okay, for question number 22, part B, we have to prove that dy upon dx is equal to log x upon 1 plus log x the whole square for this given equation. And our given equation is x raised to some function y and e raised power x minus y. So we are going to take log on both sides. So taking log on both sides we get. So this is log of x raised power y is equal to the log of e raised power x minus y. Now this is on the form log x raised power m raised power n, which is n raised power log n into log m, and this becomes x minus y. Now we can easily separate the variables. So let's take y variables on one side and take y common. So this is log x plus 1. And finally, y is equal to x upon log x plus 1. Now let's differentiate this with respect to x. We get so y is dy by dx, and this is of the form u by v. So this is differentiation of v. So v into differentiation of x1 minus u into differentiation of log x plus 1 is 1 by x upon v square, which is log x plus 1 the whole square. And this is now dy by dx is equal to log x plus 1 minus 1 upon log of x plus 1 the whole square. So finally we have dy upon dx is equal to log x upon log x plus 1 the whole square. Okay, for question number 23, we have to find the interval in which the function is strictly decreasing. And this is question number 23. Our function is f of x is equal to x raised power 4 minus 4 step. Now let's find out the first order derivative. This is equal to 4x cubed minus 12x squared. F hat x is equal to, so we are going common is 4x squared, which gives us x minus 3. Now, for strictly decreasing, f dash x should be less than 0. And f dash x is 4x squared, x minus 3. This should be less than 0 now. 4x squared cannot be, this cannot be less than 0 because x squared is always positive. So 4x squared is positive. So that means this has to be negative. So x minus 3 is less than 0, which gives us x is less than 3. So our intervals are, if we consider the number line, this is 3, this is negative, but at 0, this function becomes 0. So we cannot, at 0, this function becomes, the value of this function becomes 0. Because if we put x is equal to 0, in this case, this becomes 0 because into 0 into something is 0. So f dash becomes 0. So that means x is equal to 0, that has to be excluded. So x, and now on the number line, we have our intervals. We cannot take 0. So 0 has to be excluded. And this is 3. So our intervals are coming from, so our interval should be negative infinity to 0. 0 is not included, then 0 to 3. And 3 is also not included. So the intervals in which the function is strictly decreasing is in negative infinity to 0. This is an open interval in which 0 is not included. So 0 is not included, then from 0 to 3, where 3 is also not included, because if you put x is equal to 3, this f dash x becomes 0. So this is the union of these two disjoint intervals. So these are the intervals in which this function is strictly decreasing. So minus infinity to 0 and then 0 to 3. So we cannot take 0 because at 0, the f dash becomes equal to 0. And we cannot take 3. So these are the disjoint intervals, negative infinity to 0, then 0 to 3 are the intervals in which the function is strictly decreasing. Okay, for question number 24, it's given that the volume of a cube is increasing at the rate of 6 centimeter cube per second. Now, for question number 24, we know that cube has all its edges equal. Let L be the edge of the cube. So volume of the cube is L cube, and let S be the surface area of the cube, which is 6 into L square. Now the volume of a cube is increasing at the rate of, so that means it's given that dV by dt, that is, it's equal to 6 centimeter cube per second. Now volume is L cube, which is equal to 6. So differentiating L cube with respect to t gives us VL square into dl by dt is equal to 6. So this is dl by dt is equal to 6 by 3L squared. This is centimeter per second. And this is 2. So finally, this is the rate of change of h, which is 2 upon L square centimeter cube per second. But we have to find how fast is the surface area of cube increasing. That means we have to find the rate of change of the surface area. Now the surface area is the total surface area, which is 6 into L square. So 6 is percentage out, and differentiation of L square with respect to t is 2L, and differentiation of L, which is dl by dt. So ds by dt is equal to, this is 6 to the 12 L into dl by dt. Now dl by dt is 2 by L square centimeter per second. So this is 12 by L into 2 by L square, which is the increase, rate of change of increase in the surface area. Now this is equal to 24 by L centimeter square per second. But we have to find the increase in the surface area when the length of edge is 8 centimeter. So this has to be evaluated at length is, or edge is equal to 8. So this is 24 by 8 centimeter square per second, which is equal to 3 centimeter square per second. This is how fast The surface area of cube is increasing when the length of an edge is 8 centimeter. Okay, for question number 25, we have to find the integration of 1 upon x into x squared minus 1. So let's try to use the partial fraction method here, and this x upon x squared minus 1, I can write it as 1 upon this is a squared minus b squared. So let it be a minus b into a plus b, which is equal to a upon x plus b upon x minus 1 plus c upon x plus 1. Now, we have to find the value of a, b, and c. So this is x upon x minus 1 plus x plus 1. And this is, if we take LCM, so LCM is the product of all these. Okay, this gets cancelled, and what do we call that? So this is a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1. Now, so this gets cancelled, and finally we have 1 is equal to a into this is a square minus b square plus b into x plus 1 plus c into x minus 1. Now let's find the value of a, b, and c, and if I put x is equal to 1, so this term reduces to 0, this term reduces to 0, and finally we have b into 1 plus 1 is 2, so b is equal to half. And if I put x is equal to negative 1, so this term reduces to 0, or x is equal to negative 1, this is 0, and we have 1 is equal to c into negative 1 into negative 2, so c is equal to half as well. Now if we put x is equal to 0, so this is 0, this is 0. Now for this term, 1 is equal to a into 0 minus 1 is negative 1, so a is equal to negative 1. So that means r integration I, so I can be written as integration of this. So this is negative 1 upon x plus this is half of b is x minus 1 plus c is also half. So this is half of x plus 1 into dx. Now it's easy to integrate. This is negative log x plus half into log of x minus 1 plus half into log of x plus 1 plus c. This has to be simplified now, and this is, I can write it as, so this is 1, this can be written as x raised power negative 1, but these two half is common, so this is log of x minus 1 plus log of x plus 1 plus c. This is log a plus log b, and this is log of 1 plus x. This is log a plus b, which is log a into b. So this can be written as a into b, which is a square minus b square plus c. And for these two, if I take half common, so half, this is common. This can be written as 2 log of 1 by x plus log of x square minus 1 plus c. Now this is half 2, this is m log n, which is log, or n log m. This is n log m, which is equal to log m raised power n. So this becomes log 1 by x square plus log a square, x square minus 1 plus c. And this further can be, this is log a plus log b, which is log a into b. So this is now log a into b, which is x square minus 1 upon x square plus c. So finally, the integration is half log of x squared minus 1 upon x squared plus c. For section C, question number 26, we have to find the differentiation of the given function. And the given function is y is equal to, this is sine x raised power x into x raised power sine x plus a raised power x. Okay, obviously here the function is in power of the function, so we are going to use log, but for this only. So let's consider this. So this term only, and let's consider this term to be u. So let's say let u is equal to, this is sine x raised power x into x raised power sine x. So this function now becomes y is equal to u plus a raised power x. Now, if we differentiate this with respect to x, we can get our dy by dx. So differentiating this with respect to x, we get, this is dy by dx is equal to d by dx plus differentiation of a raised power x. Now, here dy by dx is equal to, we have to differentiate this u with respect to x. Now differentiation of a raised power x is a into log x. Okay, sorry, this is differentiation is a raised power x into log x. Let this be equation 1. Now we have to find du by dx. Let's consider our first substitution, this one, and differentiating this with respect to x. So differentiating this with respect to x, we will get our du by dx, and we will replace this in the first equation. So du by dx is the differentiation of, okay, to differentiate this, we have, so we can, so we have to take log on both sides for this. Taking log on both sides, we get, taking log on, देखिए इसमें इसका चेक करना और इसको ना रजिस्टर्स इन पैरल लिख के दो याद करने के लिए. So if we take log on both sides, this is now log u for this equation. This is log u, and this is now equal to log of sine x raised power x into x raised power sine x. So this is log u into b. So this is log u is equal to log a into b is log a plus log b. So this is log a plus this is log b. Now this is of the form, this is log u. Now this is of the form log m raised power n, which is equal to n log m. So I can write it as, this is x log of sine x, and this is of the form, also of the form log m raised power n. So this is sine x into log x. Now for both these, this is u and v, and this is u and v, and now it's ready to be differentiated. So differentiating this with respect to x, we get, so differentiation of this is 1 by u into du by dx, and for this we are going to use a product rule. So this is v into differentiation of x, which is 1, plus x into differentiation of v, which is 1 by sine x, and differentiation of sine x is cos x plus. Similarly, here use the product rule for this one. So this is log x into differentiation of sine is cos x plus sine x into differentiation of log x is 1 by x. So du by dx is equal to u into, let's try to simplify this. This is x log of sine x plus cos x upon sine x plus this is cos x log x plus sine x by x. Replacing the value of u, so du by dx is equal to u was sine x raised power x. So this is sine x raised power x into x raised power sine x. This is x raised power sine x. Now this is x log of sine x plus cos x upon sine x plus cos x into log x plus sine x by x. Okay, now let's replace this value here, which finally gives us dy by dx. So dy by dx is equal to du by dx, which is sine x raised power x into x raised power sine x into this is x log of sine x plus cos x upon sine x. So if we replace the value in that, which will be dy by dx, so 1 becomes, I'm going to write it down here, so 1 becomes dy by dx is equal to, this is u plus the differentiation of, so substituting the value here, 1 becomes dy by dx is equal to du by dx value is this plus a raised power x into log x. So this is the value of dy by dx. This is actually x. Okay. This is log sine x plus this x is here, so this is x is here. So log sine x plus x into cos x by sine x plus cos x into log x plus sine x by x. Okay, finally this can be further simplified. So dy by dx is now equal to sine x into x raised power sine x. This is log of sine x into x. Cos by sine is cot x plus cos x into log of x plus this is sine x by x plus a raised power x into log x. So this is the final answer. For question number 27, part A, we have to evaluate the definite integral. And because it's a definite integral, so let's try to use the property which says that if the limits are 0 to a and the function is f of x into dx, it can be written as 0 to a f of a minus x into dx. So using this property, our integral, let's say this is I, it becomes integration 0 to, this is pi by 4. So 0 to pi by 4 is a minus x. Right. And this is x is now pi by 4 minus x divided by, this is 1 plus cos of 2 into x is, this is pi by 4 minus x plus sine of 2 into pi by 4 x. Okay, so finally I is equal to which is 0 to pi by 4. And this is pi by 4. And let's say this be equation 1. Let's say this is I. So I is equal to this, and this is now pi by 4 minus x to 1 plus. So cos 2 into pi by 4, this becomes cos pi by 2 minus 2x plus this is sine of pi by 2 is 2x. Okay, now I is equal to 0 to pi by 4. This is pi by 4 minus x upon 1 plus. Now 90 means change, so this is in the first quadrant, so this is sine of 2x plus this becomes cos of 2x. Let this be equation 2, so let's add 1 and 2, so 1 plus 2 gives I plus I is 2i. 2i is equal to limit 0 to pi by 4, and this is the first equation, so x plus pi by 4 minus x upon this is now 1 plus cos 2x plus sine of 2x, because this is same, so it remains as it is into dx. So this is dx. This gets cancelled, and finally we have 2i is equal to pi is out. This is 0 to pi by 4. Now this 1 plus cos 2x. We all know that cos 2x is equal to 2 cos square x minus 1, which becomes 1 plus cos 2x is equal to 2 cos square x. So instead of 1 plus cos 2x, we can write 2 cos square x plus sine 2x. Now sine 2x is equal to 2 sine x into cos x. So this becomes 2 sine x into cos 2x. Okay, so I is equal to pi by 8, and this is 0 to pi by 4. Let's take 2 common in this, so this is 2 is common. So finally this is 1 upon cos square x plus sine x into cos x into dx, and this is now I is equal to pi by 16, 0 to pi by 4. Now let's divide each the numerator and the denominator by cos square x. So this is 1 by cos square x, and this becomes 1. And if we divide this with cos square x, okay, so finally this is now equal to I is equal to pi by 16, 0 to pi by 4. 1 by cos square x is secant square x upon 1 plus, now sine by cos is tan x, and this is dx. I is equal to pi by 16. Now let's make the substitution here to solve this. Let's say 1 plus tan x is equal to t, and differentiating this with respect to t gives us, so differentiating this with respect to t, we get, now the equation of tan is secant square x into dx by dt, which becomes dx is equal to dt. So this has to be replaced by dt, and this becomes t. And let's get our new limits as well. So for this, when x is equal to 0, t becomes, so when x is equal to 0, tan 0 is 0 and t is 1. And when x is equal to pi by 4, so t becomes, so tan pi by 4 is 1, so t becomes 2. And finally, our new limits are I is equal to 0, 1 to 2. Secant square x into dx is dt. This is t, which is 1 to t log. So differentiation of this is log t 1 to 2. So I is now equal to, this was pi by 16 was r. So this is pi by 16, pi by 16, pi by 16 into log 2 minus log 1. So I is equal to, we know the log 1 is 0. So this is pi by 16 to log. So pi by 16 into log 2 is the definite integral of question number 27. Okay, for question number 27, part B, we have to integrate, find the integration of this, and let's say this is our integration. And this clearly is a case of this is the function and this is its differentiation. So let me show how it is. So I'm going to write this as the first function plus 1 upon 1 plus x squared raised power 3 by 2 into dx. Okay, now let's consider this f of x. So, and obviously here it's e raised power x. So f of x is 1 upon under root 1 plus x square, and if we differentiate this with respect to x, so this is x. So it is of the form u by v. So this is of the form u, this is v, and it's v using the quotient rule, v into differentiation of u, which is 1, minus this is u, which is x, into differentiation of v, which is 1 upon 2 under root 1 plus x squared, and differentiation of x squared is 2x upon this is under root 1 plus x squared into root square. So this gets cancelled. The 2 and 2 gets cancelled, and this is now f dash x, which is equal to under root 1 plus x square minus x square upon under root 1 plus x square upon 1 plus x square. Now let's take LCM for these, simplify these. So this is under root 1 plus x square, which is the LCM, and this is now 1 plus x square minus x square. This gets cancelled, and it's 1 plus x square. So I can write this under root as raised power half, and this is finally now f dash x is finally 1 upon now half plus this power 1 is 3 by 2, so this is 1 plus x square 3 by 2. So that means this is f of x, and this is the differentiation, and now it is of the form, our integration is of the form integration of e raised power x into f of x plus f dash x into dx, which is equal to, and this integration, we know that if it is of this form, then it's equal to e raised power x into f of x plus c. So using this identity, our integration is equal to e raised power x into f of x. F of x was 1 upon, this was x upon under root 1 plus x squared. So this is x upon under root 1 plus x squared plus c. So this is the integration. I is equal to e raised power x into x upon under root 1 plus x squared plus c. Okay, for question number 28, we have find the integration, and let's say this is our integral I. So I is equal to question number 28, and this is integration of 3x plus 5. Now, if we look at the integration that's given to us, it's of the form I is equal to integration of this is a linear equation. This is a linear equation upon under root of quadratic equation into dx. And when it's of this form, we have to write the linear equation as a into differentiation of quadratic equation plus b, and we have to find the value of a and b. So let's use this. So the linear equation is 3x plus 5 is equal to a, and the differentiation of quadratic equation. So now the differentiation of the quadratic equation is x square plus 2x plus 4 plus b. Now this is equal to 3x plus 5 is equal to a into differentiation of x square is 2x plus 2 plus b, which gives us 3x plus 5 is equal to, this is 2a into x plus 2a plus b. Now if we compare this, this is 2a is equal to 3 and 2a plus b is equal to 5, which gives us a is equal to 3 by 2. And if we put a is equal to 3 by 2 here, it gives us the value of 5, which is value of b, which is 2. So that means I can write our integral now in the form this is 3 by 2. So this becomes, so this is now 3x plus 5 is now 3 by 2 into 2x plus 2 plus b, which is 2. So that means the integration is now 3 by 2 into 2x plus 2 upon under root of, which was quadratic equation x squared plus 2x plus 4. It is x squared plus 2x plus 4 plus b, which is 2 upon under root of x squared plus 2x plus 4 into dx. Okay, let's separate these integrals. So this is now 3 by 2 into integration of 1 upon under root of x squared plus 2x plus 4. This is not 1. This is 2x plus 2. 2x plus 2 plus. This is 2 is out. Now integration of under root of x squared plus 2x plus 4 into dx. This is dx. Okay, we can take 2 common here. So I is equal to 3 by 2 into 2 integration of 1 upon. Okay, let's not take 2 common here because, okay, this is the differentiation of, this is the function, and we know that integration of, if it's the differentiation upon under root of f of x is equal to 2 under root of f of x into dx. You can also get this by making the substitution. Let this be t. You can make this use the substitution method to solve this as well. I'm going to write it directly. So this integration is done, which is equal to 2 into integration of f of x, and f of x is x squared plus 2x plus 4. And now we are left with the integration of this one, and for this we will go and find the square of, so x squared plus 2x plus 4 is equal to, let's multiply this with half, which is 1. So this gives x squared plus 2x plus 4 plus, which is square of 1 minus, add and subtract the square of 1. So which this and this becomes x plus 1 the whole square plus 4 minus 1 is 3. So I can write it as under root 3 the whole square. So finally this is 2, and this is integration of x plus 1 the whole square plus under root 3 the whole square into dx. And now this is of the form. So this is now equal to I is equal to 3 under root of x square plus 2x plus 4 plus 2. Now this is of the form integration of 1 upon under root of x square plus a square into dx, which is equal to log of x plus under root x square plus a square. So let's use this. And if we use this, so I'm going to use this, the formula, implement it here, which gives me I is equal to 3. This is done. X square plus 2x plus 4 plus 2. This is log of x. X is x plus 1 plus under root x square plus a square, which is, if we open this, will be x square plus 2x plus 4 and plus c. So this is now, yeah. Okay, so this is our final integration. So I is equal to 3 into quadratic equation 2x plus 4 plus 2 into log of x plus 1 plus under root of x square plus 2x plus 4 plus c. So I is equal to 3 under root x square plus 2x plus 4 plus 2 log of x plus 1 plus under root x square plus 2x plus 4 plus c. Okay, for question number 29, part A, we have to find the particular solution of the given differential equation. So this is question number 27, part 2, and the given differential equation is dy by 3x is equal to y into cot of 2x. Now this can be written as dy upon y is equal to cot of 2x into dx. Let's use the integral on both sides. So if I use or integrate on both sides, so this is now integration of dy by y is equal to integration of cos 2x. Now integration of 1 by y is log y, and we know that integration of cot x is equal to log sine x, but this is cot 2x. So this is log sine 2x, and this has to be divided by the differentiation of 2x, which is 2. So this becomes, which is now log of sine 2x divided by 2 plus c. This is now log y is equal to log of sine 2x plus c. Now it's given that y for pi by 4 is 2. That means then when x is equal to pi by 4, y is equal to 2. So let's use this to find the value of c. So this is log 2 is equal to half log sine 2 into pi by 4 plus c. So this is log 2 is equal to half log. This is sine of pi by 3 plus c. Now sine 90. is 1. So this becomes log 2 is equal to half log 1 in C. And this is log 2. This can be written as this is half log 2. So C is equal to log 2 minus R log 1. Now log 1 is 0. So we know that log 1, the value of log 1 is 0. So C equal to half into 0 is 0. So C is equal to log 2. So this gives us the value of C, which is 2. And so this was log y. And if we replace the value of y is equal to 2, this is log 2 of log sine 2 into pi by 4, which is sine pi by 2. Sine pi by 2 is sine 90 is 1, so this is half log 1, which is 0. So c is equal to log 2, which gives us our the particular solution. So the particular solution is, if we use this equation, so this is log y is equal to half log of sine 2x plus log 2. And I can write this as log y is equal to, this is log, if we take this becomes the power. So this is log sine 2x plus log 2. And now this can be written as y is equal to, this is log a plus log b, which becomes b into under root of sine 2x. So log is 10. So y is equal to 2 under root of sine of 2x. So y is equal to 2 under root sine 2x is the required particular thing. So this is the required particular solution, that is y is equal to 2 under root sine 2x. Okay, for question number 29, part B, we have to find the particular solution of the differential equation. Now the given differential equation is, this is x into e raised power y by x plus y into dx is equal to x into dy. Okay. Now let's try to separate the variables. So this can be written as x into e raised power y by x plus y is equal to x into dy by dx. So let's just change the sides. So x into dy by dx is equal to x into e raised power y by x plus y. Let's separate both the terms by x. So this is equal to dy by dx is equal to x into e raised power y by x divided by x plus y by x. So this was also divided by x. So x and x gets cancelled. So finally we have dy by dx is equal to e raised power y by x plus y by x. Now let's make the substitution here. This is a homogeneous differential equation. So let's make the substitution. Y by x is equal to v, which gives y is equal to v into x. And if we differentiate this with respect to x, we get, so differentiating with respect to x will give us dy by dx is equal to, for its rule here, so v into differentiation of x is 1 plus x into dv by dx. So dy by dx is now equal to v into x into dv by dx. Let's make the substitution here. So this is, let's say, equation 2. Dy by dx is now e raised power v plus v. This is equation 2. So if we compare these two equations, now e raised power v plus v is equal to v plus x into dv by dx. So this and this gets cancelled. Now e power v is equal to x into dv by dx. And Yes. So this is now equal to dv upon e raised power v upon dx upon x. And this is now e raised power negative v into dv is equal to dx upon x. And integrating on both sides. So if we integrate on both sides, this is integration of e raised power negative v into dv, which is integration of dx upon x plus c. The integration of e raised power x is x, but it's negative v, so divided by v is equal to this is log x plus c. The negative e raised power negative v is equal to log x plus c. Let's the values these were on x is equal to log x plus c. Now let's get the value of c. So y is 1 when x is equal to 1. So y is 1 when x is equal to 1 gives us negative e negative 1 by 1 is equal to log 1 with log 1 is 0. So c is equal to negative e raised power negative 1. Okay, which gives us, okay, so this is now negative e is equal to log x negative e raised power negative 1. Let's change the sides. So I can write it as log x plus e raised power negative y by x. So take this to this side and change the side, and this is e raised power negative 1. So log x plus e raised power negative y by x is equal to e raised power negative 1 is the particular solution of the equation. And finally is log x plus e raised power negative y by x is equal to e raised power negative 1. So this is the particular solution. Okay, for next question, we have to solve the following linear programming problem graphically. We have to find the maximum and z subject to the constraints. This is the equation, and if you put x is equal to 0, y is 6, or y is equal to x, y is equal to 0, x is 6. And let's plot the lines and get the feasible region. So this is 6. So this is now, this is 0, comma 6, and it's 6, comma 0. Okay. Okay, so 2x plus 3y is equal to 6 is the equation. Now next is x is equal to 2. So x is equal to 2 is a line parallel to y-axis. This is x is equal to 2. And next is y is equal to 3. Y is equal to 3 is a line parallel to x-axis. So y is equal to 2 should be here. Okay. Now, how do we get the feasible region? So to get the feasible region, we will check uh, the given constraints for this coordinate 0 comma 0. So if I put 0 comma 0 where it gives me 0 is less than 6, which is true, so that means the solution region for this is towards the origin. And for x is greater than 2, if we check it for 0 is for the origin, 0 is greater than 2, which is false. So that means its solution region is away from the origin towards this. And for y is less than equal to 3, if we check it for the origin, 0 is less than c, which is true. So its solution region is so 0 for y is less than equal to 3. Actually this Actually, y is equal to 3 should be. So y is equal to 3 is here. Now, if we check y is less than equal to 3 for the origin, if you put y is equal to 0 here, which gives us 0 is less than 3, which is true. So that means its solution region is to this one. And now this is the common region. So our common region is this one. So this is the common region for all the constraints, and it has the corner points. So it has the corner points. Let me write down those, denote those corner points. So these are A, B, C, and D. Are corner points. Let me write down the corner points. So corner points are A, which is 2 comma 3. Then it's B, which is 3 comma 3. Then it's C, which is 6 comma 0. Then it's D, which is 2 comma 0. Okay, so we have got the corner points, and let's see which point, at which of these coordinates the value of z is maximum. So 2 comma 3, 3, 3, 6, 0, and 2, 0 are the corner points. Let's find out the value of z for these, which is 2x plus 3y. So this gives me the value of z for A, which is 2 comma 3, B, and it's C. So A 2 comma 3 is 2 into 2 is 4, 3 3s are 9, which is 13. So this is 13, this is 15, this is 12, and this is 4. So 13, 15, 12, and 4, and the maximum value is Z is 15, and we have to solve. So that means we have to write that the maximum value of Z is 15 at x is equal to 3 and y is equal to 3. Okay, for question number 31, part A, it's given that a card from a well-shuffled deck of 52 playing cards is lost. And from the remaining cards of the pack, a card is drawn at random and is found to be a king. So we have to find now the card is drawn, so we have to find the probability of the lost card being a king. So if a card is drawn, if the card is lost, it can be a king or cannot be a king. So these will be our two primary events. So I'm going to specify these two as E1 and E2, so that E1 be event of losing a king card. Now, if we have to lose a king card, it has to be drawn from the king cards, and we have total of 4 king cards out of 52, which gives us the probability as 1 as 13. 1 by 13. Now E2 be event of not losing a king card. So the probability of not losing a king card, it has to be from the non-king cards, and the total non-king cards are 48 out of 52, which gives us, this is uh, with 4 we can, so this is 12 and this is 13, so this is 12 by 13. Now we have to draw a king card, so we have to draw now a card, and let's say that A be the event of drawing a king from the remaining cards. So the card is lost, and now we have to draw a card, and let's say A be the event of drawing a king card from the remaining cards. So A be event of drawing a king card from from the remaining 51 cards. So when the card is lost, it could be a king or it cannot be a king. So this is the probability of losing a king card from the four king cards. This is the probability of not losing a king card, and A with the event of drawing a king from the remaining 51 cards. Now let's find out the probability of getting a king card when a king card is lost. Now, when the king card is lost, so what is the probability of getting a king card? So when the king card is lost, that is, we have lost one card, so the remaining are 51, and we have to get the king. So if the king card is lost, remaining king cards are three, so out of three, we can get the king. So now let's find out the probability of getting a king card when king card is not lost. But a card is lost, so the remaining cards are 51. Now we have to get a king, but it's uh, but the card lost is not a king card. So we have total of four king cards, so we 4 out of 51. Okay. Now what is asked in the question is that we have to find the probability of the lost card being a king. So that means that the lost card is king, and now we have to get a king when the lost card is king. So we have already got the king, and it has to be from the among the we have to find the probability when the lost card is king. We have already got the king, so this is what we have to find. That is probability of getting a king card when the lost card is a king. Okay, so using the Bayes theorem, so this is the probability of by E1 into probability of E1. Sorry, this is probability of E1 using the Bayes theorem. And once again, we have total of two events. So this is probability of A by E1 into probability of E1 plus probability of A by E2 into probability of E2. Let's put in the respective values. So probability of A by E1 is 1 by 13 into 5 by 51, sorry, 3 by 51. So this is 3 by 51 divided by 1 upon 13 in 3 by 51 plus probability of A by A2. A2 is 12 by 13 into 4 by 51. Okay. Now 13 into 51 is, so 13 into 51 is equal to 663. So this is 663 upon 3, and this is once again 3 upon 663 plus 12 into 4 is 48 upon 663. Okay, so now this is equal to 3 upon 663 divided by, now here the LCM is 663. So this is 3 plus 48. We can strike the same denominator. So this is 3 upon 3 plus 48 is 51. And this is 3 upon 51, which will finally give the answer as this is 7. So the required probability is 1 by 17. So 1 by 17 is the probability of the lost card being a king. Okay, for question number 31 part B. So this is question number 31 part B. It's given that a biased die is twice as likely to show an even number as an odd number. So that's why it's biased, because it shows even number. The probability of even number is twice the probability of an odd number on getting this die. So on a die, we have the numbers 1, 2, 3, 4, 5, and 6. So the probability of getting an even number is twice then the probability of an odd number. So odd numbers are 1, 3, and 5. So that means if, let's say, probability of odd number, that is probability of getting 1 or probability of getting 3 and probability of getting 5 is, let's say, P. Then the probability of getting even numbers are 2, 4, and 6. So the probability of getting these even numbers is twice the probability of getting the odd numbers. So this is 2p. So this is why it's called a biased die. And now if such a die is thrown twice, now this die is thrown twice, so we will get two outcomes. And we have to find the probability distribution of the number of sixes. So either the number of sixes can be zero, that is, we are not getting any six on the two throws, so zero, no sixes. And either it could be six on the first die and not on the second die, or not on the first die and six on the second die. This could be so probability of getting six on either of the die. So here we have two cases. And to get the probability of six on both the dice, so to get two sixes, these can be on both the dice. So that means let x be a random variable that shows the number of sixes on in two throws, and our random variable is x. So x represents the number of sixes. Now, what is the probability of, because it's all about getting the sixes. So now what is the probability of getting a six? So probability of getting a six and not getting a six, we have to find out. So now these are our total events. Either you get an odd number or either you get an even number. So that means either you get one, either you get two, or either you get three, or either you get four or five, or either you get six. So these are the only events uh, in throwing a die, and we know that the sum of the probability of the events is equal to 1. Now the probability of 1, 3, and 5 is P. The sum of the probabilities of 1, 3, and 5 would be 3P. So the probability of 1 is P, probability of 3 is P, probability of 5 is P. Probability of 2 is 2P, it's 2P and it's 2P. So now if we add them, so it's P plus 2P, 3, 4, 5, 6, 7, 8, and 9. So that is 9P is equal to 1. So that means P is 1 by 9. Now, what is the probability of getting a 6? So probability of getting a 6. 6 is an even number, so it says 2p, and p is 1 by 9, so this is 2 by 9. Now, probability of not getting a 6 means we are getting an odd number. So probability of not getting a 6, that means we are getting an odd number, which is p, so this is 1 by 9. Now, we have to find, now a die is thrown twice, and we have to find the probability distribution of the number of sixes. So x denotes or x be a random variable that denotes the number of sixes. So x is a random variable that denotes number of sixes. So that means x can either take the value 0, there could be no sixes, there could be one six, or there could be two sixes. So let's find out the probability of x is equal to 0. So that means we have thrown the die twice and we are not getting any six. So that means on the first row, it's not a six, and the second row is not a six. So this is 1 by, okay, so it's not a six. Sorry, so this is not, probability of not a 6 should be 1 minus probability of getting a 6, and that is 1 minus 2 by 9. It's not the odd number but not getting a 6, because we can also get 2 4. So that means we are not getting the 6 but we are getting all these, and this would be the one minus probability of getting a 6, that is 1 minus 2p, so this is 9, and 9 minus 2 is 7 by 9. So this is not getting a 6, is 7 by 9. So this is now 7 by 9 into 7 by 9. So on both the True, we are not getting a 6, so this is 49 by 81. Now, the probability of getting a 6 one time. Either we could get a 6 on the first row, that is, this is the probability of getting a 6 and not getting a 6. So on the first row, on the first die, it is 6, and on the second die, it's not a 6. Or on the first die, it's not a 6, and the 6 is on the second row. So this is two times. So this is 14 by 81 plus 14 by 81, which gives me 28 by 81. Okay, now probability of getting a 6 on both the rows, which is getting a 6 is 2 by 9. So this is 2 by 9 into 2 by 9, which is 4 by 81. So let's write down the probability distribution table. So x can take the values 0, 1, and 2, and the probability of x is equal to, or probability of x when it takes the value 0, 1, and 2. So we have got the probability distribution table. So this is the probability distribution table. Okay, let's write down the values. Probability of not, so this should be actually x and probability of x. So when we get no sixes, this is 49 by 81. This is 21 by 81 and 4 by 81. This is the probability distribution table for the number of sixes: 49 by 81, 28, and 4 by 81. This is a required probability distribution of number of sixes. And how we have to find the mean distribution. So we have to find the mean distribution, that is x mean, which is given by sigma I is equal to 1 to, this is 3, and this is pi into xi. So pi into xi means probability is 0 into this. So this is the sum of the probability with their sum of the product of the random variable with its respective probability. So 0 into 49 by 81 plus 1 into 28 by 81 plus 2 into 4 by 81, which gives me 0 plus 28 by 81 plus 8 by 81, which is equal to 36 by 81. And 36 by 81 means this is 9 4s are 36 and 9 9s are 81. So this is 4 by 9. So this is the mean of x. Mean of x. Okay, let's move on to the next question. That is question number 32. For question number 32, part A, we have to sketch the graph of y is equal to x into modulus of x, and has found the area bounded by this curve, x-axis, and the ordinates. So the first task is to sketch the graph, this, and we know that modulus of x is x when x is greater than equal to 0, and it's negative x when x is less than 0. So that means if we multiply this with x, it becomes x squared, and this becomes negative of x squared. So this is y is equal to, so let's sketch the graph for this. And to sketch the graph, let's get our coordinate axis. And let's say this is y-axis, and this is the horizontal one, x-axis. Okay, x and y-axis. Let this be the origin. These be the coordinates 1, 2, 3, 4, and 5. And these be -1 and -2 -3, -4, -5. So 1, 2, 3. Sorry, let this be 1, 2, 3, 4, and 5. So this is -1, -2, -3, -4, and -5. So if I put x as 1, which is greater than 0, so this will be x squared. So this is our first 1 comma 1. If I put 2, which is greater than 0, so 2 squared is 4. So this is 4. And this graph goes like this, the freehand curve. Now, if it's less than 0, let's say -1. So this is -1 square, so which is here -1 and 1. If I put -2, so -2 means negative of 2 square, which is -4. So if it's -2, then if it's -2, then it's -4. So this graph goes like this. Okay, now we have the ordinates x is equal to -2. So x is equal to -2 is the line, this one. This is x is equal to -2, and this is x is equal to 2. This is x is equal to 2. Okay, now our concern area, the shaded area, is this one. This is the this one with this one. And this area goes from -2 to limits. So that is our required area is equal to integration of -2 to 2y into dx. Now this area is symmetrical about x-axis. I can write it as 2 times the, if I find out the shaded areas for the limit 0 to 2, just multiply it with 2 because this region is symmetrical. These two regions, this one and these are symmetrical. So I will find the area of this region and multiply it with 2 to get the area of this region. As these are symmetrical, but the limit goes from 0 to 2, y into dx. So this y into dx, because the x is positive, so it should be x square into dx. So this is the case. And now integration of x square is x cube by 3 for the limits 0 to 2. So this is 2 into 2 cube by 3. Let's evaluate it. This is 2 into 8 by 3, which gives me 16 by 3 square units. So 16 by 3 square units is the required shaded area. Okay, for question number 32, part B, using integration, we have to find the area bounded by the ellipse and the lines x is equal to -2 and x is equal to 2 and the x-axis. But this equation is not in the standard form, and we know that the standard equation of the ellipse is x square by a square upon plus y square by b square is equal to 1. So let's get this converted into the standard form, and we are going to divide all this with 225, each and every term with 225. So this is 9 by 225 x square plus 25 upon 225 by y square is equal to 225. Okay, so this is now 25, this is 9, and this divided by 225 is 1. So this is x square upon 5 square plus 1 square upon y square upon 9, which is 3 square is equal to 1. And this is the length of the semi-major axis, that is a 5 units. So R and B. So if we compare this with the equation x square upon a square plus y square upon b square is equal to 1, if we compare these equation, which gives me a square is equal to 5 square, which is a is equal to plus minus 5, which is a semi-major axis, and similarly y is equal to plus minus 3. So that means semi-major axis and the major axis. So it goes like our ellipse goes like this. Okay. So this is 5 units. Semi-major axis is 5 units, and the semi-minor axis is 3 units. Now, there are two lines, x is equal to -2 and x is equal to 2. So x is equal to -2 is here, and x is equal to -2 is here, and x is equal to 2 is here. Okay. Now we have to find the area, and our area is this one. This is the area between the x-axis. So it's between the x-axis. So that means okay, so our area of concern is between the x-axis, x is equal to -2 ellipse, and so this is the area that we have to find. This is the shaded area. Between x is equal to -2, x is equal to 2, x-axis, and the ellipse. So let's find out this area. So the required area is equal to, it goes from the limits -2 to 2 y into dx. Okay, and y, we can get the value of y from here. So this was our equation. So it gives me y square is equal to 1 minus x square by 25, and multiplied by 3 square is 9. So y is equal to 9 by 25 is out is 25 minus x square, which gives me y is equal to 3 by 5. This is now 25 minus x square. So y into dx means this goes from the limits -2 to 2, and this is 3 by 5. So 3 by 5 is out, and it's y into dx. So let's put in the value of y, or we can write it as, because these two regions are symmetrical. So I can write it as 2 times 3 by 5, 2 times the region that goes from the limit 0 to 2. So I'm going to find the area of this region. This region is symmetrical to this region. So find the area of this region and multiply it with 2, because this gives the limits 0 to 2. So now it's 2 times the area of this region, but with the limit 0 to 2 into y into dx. So this is now 6 by 5, and y is 25 minus x squared. So 2 into 3 by 5, and here let's put in the value, which was under root 25 minus x squared. Okay, so this is 6 by 5, now 0 to 2, and now this is of the form a square minus x square. And we know that the integration of under root a square minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. So let's use this identity here, which gives me 6 by 5 is out into, so this is x by 2, so this is x by 2 under root a square minus x square, which is 25 minus x square plus a square by 2. A square is 25, so 25 by 2, and this is sine inverse of x, and a is 5. This is 0 to 2. So let's evaluate this for the limit 0 to 2. and I'm going to write it here. This is 6 by 5. Let's put in 2. So this is 2 by 2 under root of 25 minus 2 square is 4 plus 25 by 2 sine inverse x, which is 2 by 5. Okay, minus, and now let's use the limit 0, which is 0 by 2 is 0, so this is 0, and sine inverse 0, so obviously this should be 0. Okay, so finally we are left with this is 6 by 5. 25 minus 4 is under root 21 plus 25 by 2 sine inverse 2 by 5. This should be the required area. So, uh, so this is x by 2 under root a square minus x square. So 2 square is 4, 25 minus 4 is under root 21. So 6 by 5 under root plus 25 by 2 sine inverse 2 by 5. Okay, let's multiply it with, this is 25 minus 4. Okay, so this is, finally I can write it as 6 under root 21 by 5 plus, if we multiply this with, this is 6 by 5 into 25 by 2, 5 5 is 25 and 3, this is 15. So 15 sine inverse 2 by 5. So 6 under root 21 by 5 plus 15 sine inverse 2 by 5 square units is the required area. Okay, for question number 33 part A, it's given that the function is defined from set A to A and A to B, and set A is all real numbers except 5, and B is the set of all real numbers except 1. So this is question number 33 part A, and this is our domain, and this is the codomain. So this is set A, this is set B, and set A has all real numbers except 5, and B has all real numbers except 1. And this, there is a function that defined from A to B, and function is defined as this. So f of x, we have to show that f is 1 1 and on to that it's subjective. So our function is f of x is equal to x minus v upon x minus 5, and let's check it for 1 1. So let's say there are two different uh, inputs x1 and x2 that belongs to the set A, that is for all real numbers except 5. And let's consider that if f1, if their images are equal, that means that these two are not different but these two are also the same. So x1 according to this function is x1 minus 3 upon x1 minus 5. This is equal to x2 minus 3 divided by x2 minus 5. And let's cross multiply this, which gives me x1 minus 3 into x2 minus 5 is equal to x2 minus 3 into x1 minus 5. So let's multiply this. This is x1 into x2 minus 5x1 minus 3x2 plus 15 plus 15. This is x1 into x2 minus 5x2 minus 3x1 plus 15. So we can strike these two off. And finally, we have, this is negative of, this is negative of 5x1 plus 3 x1 is equal to negative of 5x2 plus 3x2, which gives me negative 2x1 is equal to negative 2x2. So this gets cancelled. That means x1 is equal to x2. So that means when the images are equal, the values of the codomain are also equal. That means for every x, there is a unique image, and which concludes that the function is 1, 1. Now let's check this function for onto. So how do we check this function for onto? We have to show that for every y there is an x, and our function is f of x is equal to, this is x minus 3 upon x minus 5. Y is equal to x minus 3 okay. Therefore, onto our function is f of x is equal to x minus 3 upon x minus 5, and f of x means it's y, so y is equal to x minus 3 divided by x minus 5. Let's cross multiply this and try to get it in the form of x. So xy minus 5y is equal to x minus 3, and this is xy minus x plus 3 is equal to 5y, which gives me negative x is equal to, okay, let's take x common in this. So x is common, which gives me y minus 1 is equal to 5y minus 3, and x is equal to 5y minus 3 by y minus 1. Now this value is defined for every value of y except 1, because here y cannot be 1, because if we put y is equal to 1, this value becomes 0 and x becomes undefined. So that means for every y except 1, so that means this here cannot be 1, which is already given. So our codomain becomes the range. Our codomain becomes the range. So we can observe that we can write that x is defined. So this x is defined for all values of y except 1. So that means our range is equal to all real numbers except 1, and this is what exactly the codomain is, which is equal to our codomain. So when range becomes equal to codomain, that means the function is onto. So that means our function is onto. So that means the function is 1, 1 and on. So given function is both 1, 1 and on. When the function is both 1, 1 and onto, it's the subjective function. Okay, for question number 33, part B, we have to check whether the relation S in the set of real numbers are defined by S is equal to A plus B, where A minus B plus root B is an irrational number, is reflexive, symmetric, or transitive. So let's check it for, first of all, let's check it for reflexive. So our relation, given relation is S, that is equal to ordered pair AB, and A minus B plus root B should be an irrational number. Then we can say that A comma B is in relation. Okay, let's check it for reflexive. And we know that for reflexive, we have to check whether we have to form the order pair of the element with itself and check whether it is in relation with they are in relation with it with each other or not. So that means instead of B, we have to take the same element A minus A. So A minus A means A minus A plus root 2 should be an irrational number according to this. So the A and A gets cancelled. So root 2 is an irrational number. So that means if we check it for A comma A, so that means A minus A plus root 2 plus root 2 is equal to root 2, which is an irrational number. So this is an irrational number, which means that A comma A belongs to the relation S. So S is reflexive. Now let's check it for symmetric. So symmetric means that if A comma B are in relation, then B comma A. So if A comma B belongs to relation F. So and B comma A also belongs to relation F. So when relation S, then we say that S is symmetric. Now it may or may not be symmetric. Let's consider this example. So I'm going to consider this example. Let's say root 2 comma 1. Now root 2 comma 1. Now root 2 comma 1 belongs to the relation Sy because this is A root 2 minus 1 plus root 2. According to this relation, A minus B, which is this is A, this is B, and root 2 minus 1 plus root 2 is 2 root 2 minus 1, which is an irrational. So 2 root 2 minus 1 is an irrational number, so that means root 2 comma 1 belongs to the relation S. So this is an irrational number. But if we change the order 1 comma root 2, now this is A and this is B. So that means A minus B 1 minus root 2 plus root 2, which is equal to 1, is an rational number. So that means 1 comma root 2 does not belong to relation S. So that means this relation is not S is not symmetric. Now let's consider it for reflexive. Now we know that relation is transitive. Let's consider this for transitive, and we know that the relation is transitive when A comma B belongs to R, B comma C belongs to relation, and A comma C belongs to relation, then we say the relation is transitive. So let's consider our relation is S. So we have to consider two scenarios where the pairs are in a relation. So the first one is, let's consider uh, an example 1 comma root. So 1 comma root 3 is in relation S because 1 minus root 3 plus root 2 is an irrational. So this is in relation. Now let's consider root 3 with root 2. So root 3 and root 2 are also in relation S, that is defined because root 3 minus root 2 plus root 2 gives me root 3, which is an irrational number. But 1 comma root 2 does not belong to S, as 1 minus root 2 plus root 2 is equal to 1, which is a rational number. So when we applied the relation 1 comma root 2, it does not belong to S. So that means our relation S is not transitive. So relation is reflexive, but neither symmetric nor transitive. So we can write in the end that S is reflexive, but neither symmetric nor transitive relation. So S is reflexive, but neither symmetric nor transitive relation. Let's move on to the next question, which is 34th question. Okay, for question number 34, we have to find A inverse, and A is a square matrix of order 3. So A is equal to, this is 2, 1, negative 3, and this is 3, 2, 1, and 1, 2, and negative 1. Okay, so let's find the determinant of A. Let's spanning it along row R1. So this is plus, minus, plus, 2, removing the row and the column for 2. This is 2, 1, 2, and a negative 1. This is negative 1. And removing the row and the column for this is 3, 1, negative 1, negative 1. This is negative 3. And removing the row and the column for this is 3, 2, 1. Okay, finally, the determinant of A is equal to 2. 2 into negative 1 is negative 2, negative 2, negative 1, negative 3, minus 1, minus 3, 3 to the 6, minus 2. And now this is determinant of A, which is 2 into negative 4 minus 1, negative 4 minus 3, and 4. So this is negative 8 plus 4 minus 12, which gives me determinant of A is equal to negative 16, which is not equal to 0. So that means A inverse exists. And how do we find A inverse? Let's find out the adjoint of A. So to find out the adjoint of A, we have to find the cofactors. So this is A11, A12, and A13. So this is plus, minus, and plus. Now removing the row and the column for A11. So if we remove the row and the column for A11, we are left with 2, 1, 2, negative 1. So this is 2, 1, 2, negative 1. And for 1, 2, remove the row and the column for 1, 2 is 3, 1, 1, negative 1. This is 3, then negative 1. And remove the row and the column for 1, 3. So if we remove the row and the column for 1, 3 for this, we are left with 3, 2, 1, 2. So this is 3, 2, 1, 2. Now this is negative 2, negative 2, which is negative 4. This is negative of negative 3, negative 1, which is 4. And this is equal to 6 minus 2, which is 4. So our first, for adjoint A, we have got the cofactors of the first row, and we have to write them in the column. So negative 4, 4, and 4. We have got the first column of adjoint A, that is negative 4, 4, and 4. Similarly, we can get the cofactors, other cofactors. So other cofactors will be 2, 1, 2, 2, and 2, 3. So this is 2, 1, 2, 2, and 2, 3. That is equal to, once again, it's 2, 1, so it's negative, it's positive, and it's negative. 2, 1 means 2 plus 1 is 3. which is odd. So we have to use negative sign. Let's remove the row and the column for 2, 1. So if we remove then the row and the column for 2, 1, so remove this one, which gives you 1, negative 3 and 2, negative 1. 1, negative 3 and 2, negative 1. Similarly here, remove the row and the column. Remove the row and the column. This 2, negative 3, 1, negative 1. 2, negative 3 and 1, negative 1. This is 2, negative 3, 1, negative 1. Okay, this is now 2, 3. Okay, if you remove the row and the column for this, this is 2, 1, 1. Minus 1, and this is plus 6. So this is equal to negative 2 plus 3. This is equal to negative 2, 4. Sorry. 2 into 2 is 4 minus 1. So we multiply this and subtract. Multiply and then subtract this product. Multiply and subtract this product. So this is negative 5, this is 1, and this is 5. So negative 5. So this is negative 5, 1, and 5. Negative 5, 1, and actually this should be 4 minus 1 is 3. This is 3. Okay, similarly, we can find the cofactors for the last row 3, 1, 3, 2, and 3, 3. So this is a 3, 1, 3, 2, and 3, 3. So 3 plus 1 is 4, so positive. 3 plus 2 is 5, negative. 3 plus 3 is 6. So guys, remove the row and the column for 3, 1. It's 3, 1. So 1, negative 3, and 2, 1. 1, negative 3, and 2, 1. And remove the row and the column for third element in the third row and second column. So if we remove this and this, we are left with 2, negative 3, 3, 1. 2, negative 3, and 3, 1. And finally, we have, if we remove the row and the column for this, we are left with 2, 1, 3, 2. So this is 2, 1, 3, 2, which gives me 1 plus 6 is equal to 7. And this is equal to negative 2 plus 9. 2 plus 9 is equal to negative 11. And this is 2 2s are 4 minus 3, which is equal to 1. So 7, negative 11, and 1. So we have our adjoint of A. This is 7, negative 11, and 1. So we have got our adjoint. We have got the determinant of A, and let's find out A inverse. So A inverse is equal to adjoint of A divided by the determinant of A, which will give us A inverse as I can write A inverse. So A inverse is negative 1 by 16, and adjoint is negative 4, 5, 7, 4, 1, negative 11, and 4, 3, 1. Okay, negative 1 by 16, negative 4, 5, 4. Okay. Now we have to use this A inverse and solve the given system of equations. Now, given system of equation, this can be written in the form AX is equal to B, where A is the coefficients of X, Y, and Z. So this is 2, and I can write X. So this gives X as A inverse into B. So X means X, Y, and Z elements are in X. And A inverse, we have already got the value of A inverse. So A inverse is, this is 4, negative 5, 7. A inverse is negative 4, sorry, negative 4, negative 5, 7, 4, 1, negative 11, and then 4 and negative 3 and 1. This has to be multiplied with the value of b. Now the matrix B is the matrix formed by the constants, that is 13, 4 and 8. So this is 13, 4 and 8. So 13, so this is 13, 4 and 8. So let's multiply this and we will get the value of x, y and z. So x, y, z matrix is equal to negative 1 by 16. Let's multiply this. So using the first row and the column, so negative 4 into 13, negative 5 into 4 plus 7 into 8. This is the first element. And 4 into 13 plus 1 into 4, negative 11 into 8. And 4 into 13, negative 3 into 4 plus 1 into 8, which is equal to negative 1 by 16. So negative 4 into 13 is negative 42. So this is 42 minus 20 plus 56. This is 42 plus 4 minus 88. And this is 42 by 52. This should be actually 52. 13 fours are is 52, fours are 12, negative 52, negative 20 plus 8 7 are 56. This is 52 plus 4 minus 88. This is 52 minus 12 plus 8. Okay, now this is equal to negative 1 by 16 and minus 52 minus 20 is minus 72. So this would be negative 72. This is negative 16. 52 plus 4 is 58. And this is 52 plus 4 is 58. 56 and 56. So this is minus 32. And 2 minus 12 is 40 plus 8 is 48. Let's divide it with negative 16, which gives me 1, which gives me 2, and which gives me negative 3. So 1, 2, and negative 3 is the value of x, y, and z. So our x, y, z matrix is equal to 1, 2, and negative 3, which gives us the value of x, y, and z as so x is equal to 1, y is equal to 2, and z is equal to negative 3. Okay, for question number 35, part A, we have to find the distance between the line and another line parallel to it. So there is a line whose equation is given, and there is another line. So let's say this is the line, and this is another line. Both lines are parallel. So this is line L1. So let's say this is line L1, and its equation is x by 2 is equal to 2y by 6. So this is 2y by 6. This is the first line whose equation is x by 2 is equal to 2y minus 6 by 4 is equal to y minus z by negative 1. And there is another line L2 whose this line is passing through the point. These two lines are parallel, that this be line L2, but this is passing through the point 4, 0 and negative 5. And these two lines are parallel. We have to find the distance, that is the perpendicular distance between these two lines. So we have to find the perpendicular distance, that is d, and we know that perpendicular distance between two parallel lines is given by the a2 minus a1 cross b vectors divided by, this is a formula to find the distance between two lines in the vector form, which is A2 minus A1, where A2 and A1 are the position vectors of the two parallel lines. So A2 minus A1 cross B divided by B vector's magnitude, and it has to be the magnitude of this as well. And for this, we have to get the lines in the vector form, or we can just get the position vectors. So our first line is N1. Let's try to write it down in the standard form. Equation of the line is x by 2 equal to, this is 2y minus 6. Let's me take 2 common. This is y minus 3 by 4 is equal to, this is, let's take negative out. So this is z minus 1 by negative 1. So we will try to get this line in the standard form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where a, b, and c are the direction ratios. So this, if we compare this line with this, the equation of the line in Cartesian form, this L1 becomes, so this is the equation of the line. Let me write this in the standard form. So this is now x minus 0 by 2 is equal to y minus 3 by 2 is equal to, this gets cancelled. This is z minus 1 by 1. This is y minus 3 by 2. Okay, so here it's position vector. I'm going to write down its position vector. So this line is passing through the point 0, 3, and 1. So A2 vector, position vector is 0 I cap plus 3j cap plus 1 k cap, which is equal to 3j cap plus 1 k cap. So this is the position vector through which the line L1 is passing, A2. And now let's find, let's say this is A1. Let's say this is A1. Now A2 is the position vector of the point through which the second line is passing. So the second line is passing through the point 4, 0, negative 5. So this is 4 I cap plus 0 j cap minus 5 k cap, which gives me 4 I cap minus 5 k cap. Now B vector. B vector is the vector that is parallel to both the lines, and this is formed by, this will give us the B vector, which is 2 I cap plus 4 j cap minus 1 k cap. So we have got A2, A1, and B vector. 2 I cap, no, sorry, this is 2. So this is 2 I cap, 2 j cap minus 2 cap. So we have got the position vectors A2, A1, and the parallel vector V. So let's find out the cross product of A2 minus A1 cross with B vector. Now A2 minus A1, let's find out A2 minus A1. So this is 4 I cap, and we don't have J cap here, so this is minus 3 J caps. Just minus them or subtract them, and minus 5 K cap minus K cap is minus 6 J cap. So this is A2 minus A1. We have to find its cross with 2 I cap plus 2 J cap minus 2 minus K cap. So 4 I cap minus 3j minus 6k is cross with 2I plus 2j plus, actually this should be k. This is plus 1. So this is our line L1. So this is plus. This is plus. And how do we find the cross? So it's I, j, and k. So now we are going to find the cross product. So I'm going to write down I, J, and K. So determinant of I, J, and K. And that is 4, -3, -6, 2, 2, and 1. Okay, this is now, we are going to expand this along row R1, so plus, minus, and plus. So this is I cap and minus V, -6, 2, and 1. This is minus J cap, and this is 4, -6, 2, and 1. And this is plus K cap, and this is 4, -3, 2, and 2. Okay, so this is now I cap. We know how to find the determinant. So this is -3 plus 10 minus J cap 4 plus 12 plus A cap 4 to the 8 and plus 6, which gives me, so 12 minus 3 is 9 I cap, 12 plus 4 is 16, -16 J cap plus 8 square is 14 J cap. So 9 I cap minus 16 J cap plus 14 K cap. This is H2 minus V1's cross B. Now let's find it magnitude of the same, which will be the square of 9 square plus -16 square plus 14 square under root. 9 square is 81. And so 16 square is 256 plus 14 square is 196 under root. So which gives me under root 533. And also let's find out the magnitude of the parallel vector. And B vector was 2, 2, and 1. So this is 2 square plus 2 square plus 1 square is under root. So this is 4 plus 4, 8 plus 1, 9. So this under root 9 is equal to root 3. Now the perpendicular distance between two lines is given by the cross product of the difference of the producing vectors with the parallel vectors magnitude divided by the magnitude of the parallel vector. So this is root 5 3 divided by 3 units is the perpendicular distance between these two parallel lines. Okay, for question number, this is question number 35th, part B. And we are given with the lines. This is question number 35th, part B. And the lines are, these two lines are perpendicular to each other. And the line L1 is given by x minus 1 by -3 is equal to y minus 2 by 2k is equal to z minus 3 by 2. And another line L2 is x minus y by 3k is equal to y minus 1 by 1 is equal to z minus 6 by -7. And both these lines are in the standard form because the Cartesian equation of the line is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where x1, y1, and z1 are the coordinates of the line through which this line is passing. These two lines are in the standard form. This is the standard form of the equation of the line in the Cartesian form. And if we compare these two lines with the standard form, these are the direction ratios. So the direction, we can write the direction ratios of L1 are -3, 2k, and 2. And similarly, the direction ratios of L2, these are 3k, 1, and -7. And these lines, that is, L1 is perpendicular to L2. So if L1 is perpendicular to L2, that is the sum of the part of the direction ratios A1 into A2 plus B1 into B2 plus C1 into C2 should be equal to 0. So this is -3. Now A1 into A2 is, let's put in the values, -3 into 3k. These are A1, these are A1, B1, C1, and these are A2, B2, C2. These are the direction ratios. So -3 into 3k plus 2k into 1 plus 2k into 1. 2k into 1 plus c1 into c2. c1 into c2 is 2 into negative 7. Is 2 into negative 7. This should give me the value of k. So minus 9k plus 2k minus 14 is equal to 0. Minus 9k plus 2k is minus 7k minus 14 is equal to 0. Minus 7k is equal to 14 and k is equal to negative 2. So the value of k is negative 2. And now we have to find the equation of the line which is perpendicular to both L1 and L2. Okay, for that we are going to use the direction ratios of L1 and L2. So direction ratios of L1 and L2 are here, and the line, or let's say the vector, perpendicular to both L1 and L2. So equation or the vector that is parallel to L1 and L2 is given by I cap, J cap, K cap, and we have to write these, the direction ratios, and the first one. So if we put in the value of this, so this gives me k is negative 2, so this is minus 3, 2 into negative 2 is minus 4, 2, and these direction ratios are now 3 into negative 2 is negative 6, 1, and negative 7 if we use the value of k is equal to negative 2. So these are the direction ratios, negative 3, negative 4, 2, negative 6, 1, and negative 7. Now the vector which is parallel to L1 and L2, let's say this is the B vector, is given by minus 3, minus 4, determinant of this is minus 6, 1, and negative 7. Okay, so this will give us the B vector. So this is now equal to, this is positive, negative, and positive. So I cap and the determinant of minus 4 to 1, negative 7, minus J cap and the determinant of minus 3 to negative 6 and 7. Then it's plus K cap. This is minus 3, minus 4, negative 6, and 1. Okay, finally, this P vector is equal to, this is I cap into 28 minus 2 minus J cap into minus 21 plus 12 plus K cap into minus 3 plus, this is negative 24. Negative 24, which gives me B vector as this is 26 I cap, this is 0, and minus 27 K cap. So this is our B vector. So this is the vector that is parallel to both L1 and L2, minus 3, minus 3, minus 4, minus 2. Okay, let's check in the second term. So if you do the j minus 3, 2, 6, and this is actually negative 7. So this is plus 21. This is actually plus 21 and 12, which gives me negative 21 plus 12 is 3, 3 j cap, and negative 27 k cap. So these are vector that is parallel to both lines L1 and L2. 26 I cap minus 33 j cap minus 27 k cap. Now equation of a line. So equation of the line that is passing through 3, negative 4, 7 and parallel to a vector is given as R vector is equal to lambda into A vector plus B vector, where A is the position vector of the point through which it is passing. So R vector is equal to its position vector would be, this is 3i cap minus 4j cap plus 7k cap into lambda plus parallel to b vector. B vector is 26i cap minus 33j cap minus 27k cap. So this is the equation of a line that is passing through the point and parallel to p vector. We have got the parallel vector 3i cap minus 4j plus 7k plus lambda into lambda plus 26. So this should be here, lambda into p vector. Okay, for question number 36, that is a section E. In the section, there are three case study based questions of 4 marks each. And the first one says that a store has been selling calculators at rupees 350 each. And a market survey was conducted which shows that the reduction in price P of calculator will increase the number of units X sold. And the relation between the price and the quantity is given by the demand function. This is the demand function. And based on the above information, we have to answer the following questions, which says that we have to determine the number of units so that the revenue is maximum. And the revenue is given by the function R of X is equal to X into P of X. So this is the revenue R of X is equal to X into P of X, where P of X is the demand function and P is 450 minus X by 2. So this is equal to X into 450 minus X by 2. So R of X is equal to X into 450 is 450X minus X square by 2. We have to find the number of units for the maximum revenue. And for maximum revenue, let's find out its first order derivative, and we should go for the maxima and the minima. So the first order derivative is 450 minus this is 2x by 2. So this is now 450 minus x. And for we know that for the maxima or the minima, the critical value, we can get the critical value by equating this first order derivative to 0, which gives me 450 minus x is equal to 0. So that means the number of units sold should be 450 to maximize the revenue, and we have to verify the result as well. So to verify the result, we have to find the second order derivative. So its second order derivative, the second order derivative is r double dash x, which is equal to -1, which is less than 0. So that means r of x is, that is, the revenue is maximum when x is equal to 450. So this verifies our result. And for the second part, we have to find the rebate in price of calculator that the store should give to maximize the revenue. So the revenue is maximum when the number of calculators sold are 450. And let's find out the price when x is 450. So price of a calculator is 450 minus x by, and x is 450. So this is 450 minus x is 450 by 2, which gives me 225. So this is 450 minus 225, which is now equal to 450 minus 225 is 225. So this is the price of a single calculator at which, so this is the price at which the store should sell a single calculator, and the number of units sold should be 450 to get the maximum revenue. And let's check what rebate this store is going to offer. So this store is going to offer, initially this store was selling calculators at rupees 350 each. Now it has reduced the price to 255. So the rebate is a discount offer. So 350 minus 225, which gives us rupees 125. So they have to reduce the price by 125. So to get the maximum profit and the number of units the calculator should sell be is 450. Okay, for question number 37, an instructor at the astronomical center shows three among the brightest stars in a particular constellation, and these are the three stars. So, telescope is located at the origin. So, this is the telescope that is located at the origin, and all the three stars have the locations at D, A, and V with these position vectors. This is the position vector of A. This is position vector of A. Sorry, D. The first one is D. So this is the position vector of D. This is the position vector of A, and this is the position vector of B. So based on the above information, we have to answer the following question. How far is the star V from star A? The first one is we have to find the distance VA. For that, let's find out the vector VA. So vector VA would be the position of A minus position of B, or let's write it down as AV. So AV is equal to position vector of V minus position vector of A. Now, what is the position vector of V is minus 3i cap plus 7j cap plus 11k cap minus position vector of A, which is 7i cap with 5j cap plus a cap. So this is equal to minus 3 minus 7 is minus 11 minus 10. So this is minus 10 I cap. 7 minus 5 is 2j cap. 11 minus 8 is 3j cap. So this is AV vector. Now we have to find the distance, that is, we have to find the magnitude. So that is the sum of the square of the scalar components minus 10 square plus v square under root, which gives me 100 plus 4 plus 9. And that is equal to under root 9 plus 4 is 13. So 100 root 113 units is the distance of A from B. Now we have to find the unit vector in the direction of dA, vector dA. So let's find out the dA vector first. So let's find out dA vector first. So that would be the position vector of A minus position vector of D. Now position vector of A is 7i cap plus 5j cap plus 8k cap minus D vector. So D vector here is 2, 3, 4. So this is 2i cap plus 3j cap plus 4k cap. So this is equal to 7 minus 2 is 5i cap. 5 minus 3 is 2j cap. And 8 minus 4 is 4k cap. Now this is dA vector. And let's find out its magnitude as well. That is the sum of the square of the scalar components of dA vector. Okay, so this is 5 square is 25 plus 4 plus 16. 16 plus 4 is 20. This is under root 45. And under root 45, everything has 9 into 5. So this is equal to 3 root 5 units is the dA vector. We have to find the unit vector in direction of dA. So let's find out now the unit vector in direction of dA vector is equal to dA vector divided by its magnitude. Now dA vector is 5i cap plus 2j cap plus 4j cap divided by 3 under root 5. So this is the unit vector in the direction of the dA vector. Okay, the third one is to find the measure of angle VDA. So VDA is the this is the angle between VD and DA vector. So we have got DA vector. Let's find out VD vector for third one. Let's find out DV vector for now. We have to find angle VDA. So angle VDA is angle between angle VDA is angle between DV and DA vector. So DV, so this is angle between DV and DA vector. So we have already got the DA vector. So let's find out DV vector first. So DV vector is equal to position vector of V minus position vector of D. Now position vector of V is minus 3, 7, and 11. So this is minus 3, 7, and 11 k cap minus D. So D vector is 2, 3, 4. So this is 2 I cap plus 3j cap plus 4k cap. Okay, now this is equal to negative 3 minus negative 2 is negative 5I cap, 7 minus 3 is 4j cap, and 11 minus 4 is 7k cap. So this is our D vector, and because let's find its magnitude as well. So magnitude of D vector is equal to minus 4 square, sorry, minus 5 square, 4 square, and 7 square under root, which gives me 25 plus 16 plus 49. Okay, so dv vector is equal to, this is 9, 6, 15 plus 5 is 20, and 4 plus 5 to 7 and is 90, under root 90. Under root 90 is 3 under root 10 units is the dv vector. Now we have to find the angle between dv and da. So dv and d's dot product is equal to magnitude of dv into magnitude of dA. That will give me cos theta. So theta is equal to the dot product of dA and dV divided by their respective magnitudes. So dV dot dA and dV vector is minus 5I cap plus 4j cap plus 7k caps dot product with dA, and dA vector is 5 to 4. 5, 2, and 4k cap. This is k cap divided by the magnitudes, and the magnitudes are 3 root 5 into 3 under root 10. So this is actually cos theta. So cos theta is equal to minus, let's find the dot product, that is negative 25 plus this is 8 plus 7 fours are 28, and this is 3 under root 5. This is 5. So this is 9 under root 50, and now cos theta is equal to negative 25 plus 28. So okay, so this is negative 28 minus 25 is 3 plus 8 is 11, 9 root 50. We can rationalize this by root 50, which gives me 11 root 50 by 9 into 50. Okay, so that should be equal to cos theta is equal to, this is 11 root 50 by 450. So 11 root 50 by 450, and I can write root 50 as, root 50 can be written as 25 into 2 upon 450, which gives me cos theta is equal to 11 into 35 is 5, and the root 2 by 450. So this is 90, which gives me 11 root 2. So this is 11 root 2 by 90. Okay. So let me just verify this. Okay, so this is 11 root 2 by 90 is, if you have to find the angle, so theta is now equal to cos inverse of 11 root 2 by 90. So this is the angle between the angle VDA, which is between dV vector and dA vector. And okay, so what is the projection of dV on dA vector? So we have to find the projection of, this is also part 3 or, so we have to find the projection of, the second one is dV vector on dA vector. So that should be equal to the dot product of these two dV into dA vector divided by the magnitude of dA. So this is the projection of dV on dV, and we have already got the dot product. So dot product is 11. So this is 11 and magnitude of dA. So we have got the magnitude of dA. So this is the magnitude of dA, which is 3 root 5. So this is 3 under root 5. And we can rationalize this. So this is under root 5, which is equal to 11 under root 5 by 50. 11 under root 5, 15 is the projection of the vector on the vector. For question number 38, it's given that Rohit, Jaspreet, and Alia appeared for interview for 3 vacancies in the same post. One has to be selected. Probability of Rohit selection is 1 by 5, Jaspreet's is 1 by 3, Alia's is 1 by 4, and the events are independent of each other. So what is the probability that at least one of them is selected? So let's write down what is given to us. So probability of Rohit's selection is 1 by 5. Probability of, let's say, just pre-selection is P of J, which is 1 by 3. And probability of Alia's selection is A, which is 1 by 4. Let's find out the not probabilities. Probability of Rohit's not selection is 1 minus 1 by 5, which is 4 by 5. Similarly, probability of this pre-not selection is 1 minus 1 by 3, which is equal to 2 by 3. And probability of all Ya's not selection is 1 minus 1 by 4, which is 3 by 4. Okay. So what is the probability that at least one of them is selected? So probability that at least one of them is selected, which means either one of them is selected. So this is exactly the opposite of probability that no one is selected. So let's subtract it from 1. So if you subtract the probability of no one is selected, that means at least one of them is selected. So 1 minus probability of no one is selected means the probability of this not selected, Rohit not selected into probability of this street not selected into probability of Alia not selected. So this is equal to 1 minus 4 by 5 into 10 by 3 into 3 by 4. Okay, which gives me this gets cancelled, and which is 5 equal to 1 minus 2 by 5, which is equal to 3 by 5. So probability of at least one of them is selected is 3 by 5. Okay, and now let's find out the next one is to find out next question is to find probability of G by H naught, where G is the event of the free selection and H denotes the event that Rohit is not selected. So second one is probability of G by H naught. And this is the formula probability of A by V, which gives A intersection B upon probability of B. So for this, it would be the same probability of G intersection H naught upon probability of H naught. Because these are independent events, and for independent events, probability of A intersection B is equal to probability of A into probability of B, because there is nothing common. For independent events, probability of A intersection B is zero. So probability of A intersection B is equal to probability of A into probability of B for independent events. So this is D for independent events. Because it's given that all these are independent events. So for independent events, this is the case. So this becomes probability of V into probability of H naught divided by probability of H naught, which gets cancelled. Now the probability of G is the only thing that remains, and G is the event of just free selection, which is equal to probability of V, that is equal to 1 by 3. Okay, for next question, next part, we have to find the probability that exactly one of them is selected. So there are three. So probability that exactly one of them is selected means that one is selected and the other two are not selected. So that means we can write it as that first Rohit is selected. Here, let's say Rohit is selected and others are not selected. So Jaspreet is not selected and Alia is also not selected plus. Either this could be the case or Rohit is not selected, Jaspreet is selected into Alia is not selected, or this could be the case Rohit is not selected, Jaspreet is not selected and Alia is selected. Okay, let's put in there respective probabilities. Probability of Rohit getting selected is 1 by 5. So this is 1 by 5. The speed not getting selected is 2 by 3. And Alia getting selected is 1 by 4. So Rohit now not getting selected is 4 by 5. The speed getting selected is 1 by 3. Alia not getting selected is 3 by 4. Rohit not getting selected is 4 by 5 into Jaspreet not getting selected is 2 by 3 and Alia getting selected is 1 by 4. Okay, this gives me 2 by 5 is 15 and 4 is 60 plus. This is 12 by 60 plus. This is 8 by 60, which gives me 60 by 8 plus 2 is 10. This is 22 by 60. This is 11 by 30, which is equal to 11 by 30 is the probability. Actually, this is 1 by 5, and the strings not getting selected is 2 by 3, and are you not getting selected is actually 3 by 4. So this is 3 by 4, which means this should be 6 by 60, and then it's now 20 and 26 by 60, which gives me 13 by 30. So 13 by 30. Okay, now let's do its OR part. So it says we have to find the probability that exactly two of them is selected. So probability that exactly two of them is selected. So that is equal to probability means we have to select two. So Rohit is selected, the speed is selected, and Halia is not selected. Or Rohit is selected, the speed is not selected, and Halia is selected. Or this could be Rohit is not selected, and Jaspreet and Alia are selected. So Jaspreet and Alia are selected. Okay, so now probability of Rohit getting selected is 1 by 5. Jaspreet getting selected is 1 by 3 into Alia not getting selected is 3 by 4. Now it's 1 by 5. Jaspreet not getting selected is 2 by 3. Alia getting selected is 1 by 4. Rohit not getting selected is 4 by 5. Jaspreet getting selected is 1 by 3. Alia getting selected is 1 by 4. So this is equal to 3 and 60 plus 2 and 60 and 4 and 60, which gives me 9 by 60. Okay, so that should be equal to T by 20. So T by 20 is a probability that exactly two of them are selected. And with this, we are done with the first set of. So with this, we are done with the fourth set. This is the fourth set and subset one of 2024. Thank you for watching.